Hi, my name is Chris, and I'm a research scientist at RadiaSoft. Today, I'm going to be doing a demo of RadiaSoft's Sirepo interface for the particle tracking code Elegant, and showing you how to create a photo lattice in Elegant with Sirepo. So if you want to follow along or try this out, you can go to sirepo.com in your web browser, or we'll have a link to that in the description for this video. So if you go to sirepo.com, you'll see this page here. And to get started, you can click on the supported codes button here at the top, and we'll get a drop-down menu. And we're going to select Elegant from that list. So that brings you to the this kind of landing page for Elegant in Sirepo. When you first go to this, if you aren't logged in, you'll be greeted with a prompt to enter your email address. And that's just so that you can have a saved workspace so that whenever you access Sirepo from any device, you'll be able to get any of your simulations wherever you are. You'll see there's an examples folder here. This just has a few pre-built Elegant simulations that you can try out or edit. If you're coming with an existing set of Elegant files and lattices you want to try out, you can do that with this import button up here in the top right. You click on that, you can import your command file, lattice file, and any supporting files, and just get started using them in Sirepo. But for now, we're going to assume that we just want to start with a brand new simulation. So we're going to click on this new simulation button here at the top. And we're going to need to enter a name for our simulation. We'll go ahead and call that FODO and say Save Changes. All right, so that brings us into the interface for setting up our simulation. You can control where you are in the interface with these tabs up here on the top right. You'll notice right now I'm on the Source tab. This provides an interactive set of controls where you can adjust the input distribution that you're using in your Elegant simulation. And you'll see previews of what the distribution looks like as you change parameters. For today, we're not going to worry about the distribution. We're just going to focus on actually setting up a brand new lattice. So to do that, I'll go in the top right here to the Lattice tab and click on that. And that brings me into a new screen. Now you can see there's not that much here right now. We have a little box for our Beamlines. This is going to hold a listing of existing Beamlines as we create them. So in Elegant, as in most tracking codes, we have a Beamline, which is just a container that holds the listing of elements that you're tracking through. It can also contain sub-beamlines to help you organize and group similar sections of your lattice together and repeat them. There's also a listing for beamline elements that will hold all the elements as we go through and create them. For now, I'm going to start out by clicking on the new Beamline button and the Beamline box. And again, I need to enter a name for this. We'll also call our Beamline Photo and say Save Changes. So you can see a few new things pop up. We've got our photo Beamline, which is empty for the time being. And then on the left, we have our lattice viewer that's going to show a schematic preview of our lattice as we build it up. And at the bottom left here, we have our Beamline editor, where you can add new elements and rearrange elements to create your Beamline. So to get started with elements, I'm going to go to this Beamline Elements box and click on New Element. And that gives me a listing of basic elements available in Elegant. I'm going to start out with a drift, which is abbreviated drift in Elegant, and click on that. And I now get a list of all the parameters that describe a drift. So I'm going to change the name of my drift to be full, and I'm going to set its length to 1 meter. And save changes. So now I've got my full drift listed here under my Beamline elements. And if I want to add that to my lattice, I can just hover my cursor over this full icon. You'll notice I get now this little crosshairs icon. If I click and hold down on that, I now get a full icon I can drag around. If I release that in the Beamline editor, you can now see that full has been added to my lattice. And you get a preview of that drift, which is just a gray rectangle. now up in the lattice viewer. So let's go ahead and add a few more elements. I'm going to need another drift, so I'll go back over and select a new element, drift, and I'm going to call this drift half, and we'll make that 0.5 meters. So you notice, kind of by the implied naming scheme here, there should be a relation between my full and my half drift. The half drift length should be half of the full length. So if I want a better way of setting this, I can go and use this variables button here. If I click on that, I can now start to name and define variables that will be saved and can be used in parameters for my elements. So I'm going to make a variable called full_length. We'll set its value to 1 meter. And now we'll make a half length variable that I'm going to define in terms of my full length. So we can use that full length variable here in the value, and we can now evaluate expressions as well in this box. So we'll do full length divided by 2. And you can see to the right, as I add to the expression, an update of the value is shown here. So we get our expected half a meter. For anyone who might already be familiar with using Elegant, you know that it uses reverse Polish notation for entering expressions. That's also supported in the interface. So if I wanted to use reverse Polish notation, I would do full length to division symbol. And we get the same result here. So whatever you're more comfortable with using, that's available. So we'll go back to standard notation. And then I'm going to add in one more variable, anticipating that I will need it later on. We'll call that quad strength. And we're going to set that to 5 for the time being. Click Save Changes, and those variables are now all saved. I'll go ahead and edit my drifts, which you can do by going to the line of the element here in the element box and clicking Edit. It brings up the parameter list, and we will change the length to full_length. And you can see, again, there's an update of the evaluated expression for the length parameter shown here. We have that expected 1 meter. We'll also edit our half drift in the same way. And now, if we want to finish off our photo lattice, we're going to need some focusing elements, so quadruples. So I'll go back to the new element button, click on that, and now I'm going to select the quad element. We'll name this quad F for quad focusing. We'll set its length, and then I'm going to use that quad strength variable I defined to define the K1 value of the strength. So notice there are a lot of parameters now for the quad. If you don't know what a particular parameter is, you can always hover over this little eye icon to the right of each parameter name, and that will give you a brief description of the parameter taken from Elegant's documentation. Another thing to note of, there is a list of pages across the top here for the quad, since there are more parameters that can fit on one page. So anything that's available in Elegant to describe a quad, you can always find by going through these pages and setting the appropriate parameter. But for now, we're just going to focus on setting the length and the strength. We'll say Save Changes. And now we're going to need a defocusing quad. So a new element again, quad. We'll call this quad D for defocusing. Set the length to 1/4 meter. And now if I want to set the strength, I can use that quad strength variable. But now for a defocusing quad, it needs to be negative. So we can also define expressions for parameters. I'm going to enter just a minus sign here. And you see that updates now the evaluated expression for the strength parameter to be -5. Say Save Changes. And now I'm all ready to start building my lattice. So to add additional elements, it's going to be that same procedure that I showed before. We're going to hover over and then hold down and drag and drop. But now if we want to adjust the ordering of elements, if I bring my cursor all the way over next to my existing full drift, you'll see this little gray box pops up showing a preview of where my half drift is going to be placed when I release my mouse. So I want this actually to be in front of the full drift in the beamline. So I'm going to bring it over to the left and then release that. And now add in my quads. So focusing quad will come first. I'm going to place that between the half and full drift, dragging it to the middle here. And you can see now that the lattice view is a little more exciting. We've now got our half drift, the quad as represented by this red rectangle, and then our full drift, all shown to appropriate scale. So let's add the defocusing quad now, and a final half drift to make a symmetric lattice. So this completes my FODO cell. If you decide that maybe some of the parameters you have set are inappropriate or you forgot to set something, there are some additional options to be aware of for editing the beamline as you go. If you go down to the editor and you just click once on one of the elements, like the focusing quad, you'll note that the corresponding block in the lattice viewer is highlighted in yellow, showing you what you selected. If you go then to the element in the editor and double click on it, you'll be greeted by that same parameter page, and you can make edits here to the parameter as appropriate. Likewise, if you go up to the viewer and hover over the focusing quad, you can see that if I now double click on that, I get the same parameter page. So this can be useful if you don't remember the name of your element, but know where it is along your beamline. Makes it easy to make changes as you go. All right, so let's now see how we did on building the lattice. If I want to get a little preview of the properties of the lattice, I can go to this twist parameters button in the bottom left of the lattice viewer and click on that. And this is going to run a quick, elegant simulation, just evaluating the twist parameters for our lattice and plot them for us. So you can see the plot comes up after the simulation is finished. And if you want to know what quantities are being plotted, there's a listing down in the bottom left here. You see we have the twist beta x and beta y, as well as the dispersion function, eta x. Since we don't have any bending elements in our beamline, eta x is just going to be 0 everywhere. And if we want to turn that off, we can just click on this check mark to the left of eta x, and that won't appear on our plot anymore. You'll also notice that along the top, there is a schematic again of our lattice, showing the position of the drifts and the quads. And you can also even here double click on one of the elements to edit it. If we want to edit the plot now and see some different quantities, we can go up to the top right of the plotting window, and there's this pencil icon. If I click on that, I now have drop downs for up to 3 different quantities I want to plot. So let's try out the twist alpha values. So we'll select alpha x from this drop down and alpha y. And while I'm here, I'll go ahead and turn off that eta x, since we won't be needing that. You can also toggle the lattice overlay here if you need to. So let's save changes, and the plot will update. And you can see now we've got alpha x and alpha y plotted, still periodic and matched as you would expect for a FODO cell. So we'll close out of that. And now one last nice feature for manipulating beamlines in the Sirepo interface. If we want to add in a new beamline consisting of our previous beamline elements, we can pretty easily do that if we select now our full drift. I'll be highlighted. And I can now go over to the end of my beamline, and if I hold down on Shift on my keyboard and click on this half, I'm greeted with this pop-up to name my new beamline. And we'll call this just the default of BL1 and say Save Changes. And you can see now that I've got 2 beamlines, my FODO cell, which is now defined in terms of 2 elements, and this sub-beamline, BL1. If I select that down in the beamline editor, you can see that now the entire sub-beam line is highlighted, showing me its definition in the lattice viewer. All right, so now if we want to actually run a full simulation, we can get started by first going to the Control tab and clicking on that. So this is where, if you want to adjust the command name lists, add new commands, or edit existing commands, you can do so. For existing commands, you just highlight over them and there'll be an option to edit, or there's this new command button that gives you access to any command name list available in Elegant. For our purposes, the default setup should be just fine, so we aren't going to change anything here. To actually run the simulation now, we're going to go to the top right to the Visualization tab and select that. You'll get a new window here. You can see there's a Start Simulation button if we're already, and there's this drop down to select our beamline. You can see we've got our FODO and BL1. We'll run the full FODO beamline, so keep that selected. If you want a little more control over how your simulation is being executed, there's also this pencil icon in the simulation status box. You click on that, you can see you have access to either selecting serial or parallel execution for Elegant when it's run on our servers, or there is a backtracking option that can be selected as well, toggle here. And what this does is reverses the order of elements in your beamline. And this can be useful if you know your output distribution and you want to find the corresponding input distribution that you want to get to. We'll leave all this as is. This should be a pretty quick simulation, so serial execution will be just fine. We'll close out of that and we'll start a new simulation. So that'll get started. This should just take a few seconds to run. All right, so our simulation is done. And you can see a few new boxes pop up. And each one of these is corresponding to output files that have been produced by Elegant. So there is at the top this output parameters box. This is where you can access parameters or scalar data that's been produced by Elegant. You can select different files from this drop down here. We'll briefly look at the twist output, which has useful quantities such as, for instance, your max beta function along the beamline. So this is pretty large. If you want to hide that, you can go to the top of the box and click on this little arrow here, and that will hide the output for the time being. I'm going to also hide the centroid plot, and we'll go ahead and look at the twist plots. So if I click on that arrow again to now show the plot, we can see we're currently plotting beta x versus s, the position along the beamline. If I want to change the plotting quantities here, I can click on that pencil icon in my twist output box. And I can now adjust the quantities to plot under the vertical set of dropdowns. Let's go ahead and add alpha x to our plotting list. You can see now for these plots in the visualization output that you also have the option to change what you're plotting against. But we'll leave that on S, position along the beamline for the time being. If you want more control over the plot, there's also options for setting the plotting range. For instance, if you want to actually fix particular values for your horizontal and vertical ranges, you can do so here. We'll leave that on automatic for the time being. There's also a toggle here to show the lattice overlay. I'm going to go ahead and switch that on and say Save Changes. You'll see the plot now updates, and we now have the lattice displayed here. Note that you can again hover over elements in your lattice, see their name, and double click on the element if you want to edit it from the visualization window. So for our plotting output, if you now want to save the plot you've made, you can click on this cloud and arrow icon here, and that'll bring up a drop down with 3 different sizes of plot that can be saved in PNG format. Or if you want to do more plotting, perhaps that isn't enabled through the Sirepo interface, you can download the raw data. Selecting the raw data file download here, we'll download a file in STDS format, which is Elegant's native format for storing data. Or there's also the option to have that file converted to comma separated value format and download it in CSV. So in addition to having the option to download the output data, let's say you want to adjust your simulation or be able to run it locally. That option is also available through Sirepo. If we go up to the very top of the window now and click on this gear icon, we get another drop down. And there are a few different ways now to export the entire set of simulation file definitions. So one of those that you might want to use most commonly is just the Python source button. All this does is create a Python script that defines the elegant input files. Then we'll save them and try to run those using elegant on your system when you execute it. A little bit more advanced option, there is export as zip. This creates a zip file that not only contains that Python source script, but also a JSON file that describes the entire setup of the elegant simulation on Sirepo. And then the other nice part of the export as zip is that if you have any externally defined files that you've loaded in, say a distribution or definitions for wake fields, those will also be bundled in the zip file and used to run the simulation. The final option here is exported as MADX lattice, and this will convert all available elements in your lattice over to MADX format and create a file that can be executed using MADX locally. The final option I want to mention, if you want to share your simulation through Sirepo, though, is that that's really easy to do. You can just go over to, you can see the lattice name here, and to the right of that is this little chain icon. If you click on that, you get the simulation URL, which you can go ahead and copy. And now if you provide this link to anybody, they'll have the option to copy your simulation in its current state and begin working with it directly on the Sirepo interface. So that concludes the FODO tutorial. Thank you for watching.